An important part of understanding functions from an abstract level on the CLEP is, can you determine whether a rule assignment yields a function or not? That is, if I give you a rule for how to manipulate your input x, is your output unique for each value of x? That is the main quality of being a function for us. So let's look at an example. Right, so just to reiterate, I have to assign a unique output to an input. So if I look at pictures here, on the left I have the plot of the function y equals x squared minus 1. I have the x-axis plotted on, well, the x-axis and the y-axis plotted on the y-axis. So for each value of x, say x equals 1, I look up and I get a unique value of output. Over here at minus 1, I also get a unique value of output. So I'm thinking that if I draw sort of vertical lines here, I'm only ever hitting my graph one time. But we'll sort of go into more detail for this in the next section about this idea of using vertical lines. So this indicates to us that y equals x squared minus 1 is a function. Instead of thinking of y here, you can think of f of x. So I'm plotting f of x on the y-axis and x on the x-axis. Over here, though, on the right, I have the plot of a circle. And things seem a bit more complicated here. For a particular x value, say x equals 0, there are two corresponding y values. Similarly, at x equals 1/2, there are two corresponding y values. So I'll just say remark, on the circle, an x value isn't assigned a unique y value. And this tells me that the circle is not a function. I do not have a unique assignment of inputs to outputs if I think of my input as x. Now, for both of these examples, I drew vertical lines. And this indicates the most quick and efficient way to test if a function, if a rule assignment is actually a function. It's called the vertical line test, and it's something we'll talk about in just a moment.